How could the car's acceleration be made to increase? So I want you to stop this video here in a second. Just pause it. I want you to think of some ways, just make a little list of some ways that you could think of to increase the acceleration of the car so it's even faster than 210 miles per hour at the end of 2.5 seconds. Okay? So think of some ways that could happen. Go ahead and pause the video now. Okay, so some ways that usually students come up with is they think of, well, we could decrease friction. Okay. Another way is people say that they could increase the pressure, and usually I ask them, okay, if you're increase the pressure, how would you go about doing that? And usually students say, put more propellant inside of the thing. So they're talking about more mass of the water there. I also asked them, okay, what if we did look at mass a little bit more? Is there anything, let's say the water stays constant, so that mass is constant. Could we do anything about the mass of the car? And usually students say, well, if we decrease the mass of the car, then we could change the acceleration. So we've got increased amount mass of water, and that will cause more of a force that they're saying. And they said that we could decrease the mass of the car. Friction, there's some other things. Students start thinking about air resistance, making it more aerodynamic. They generally talk about having different accelerations due to gravity, that kind of stuff. We can't really affect the acceleration due to gravity. We're going to ignore friction for right now because it'll be simpler. So there's two things. We can change the mass of the car, or we can change the force that's causing the acceleration. There's two things that we're going to look at. So that's what we're going to do now in lab. Okay, so this is the simulation you guys are going to be doing. Unfortunately, we're not in class today, so you won't be able to actually work with the fan cards. I've been charging all night. But you'll be able to get the data from this simulation as well. So what the simulation is going to look like, it's going to be this person pushing this refrigerator or something like that. And there's two things you're going to be able to change. This is what it's going to look like when it opens up. You're going to be able to change the mass of the box. And you're also going to be able to change the amount of applied force. So what we're trying to do is we're trying to figure out what's the relationship between the acceleration and the net force. And there's only going to be one force here, just the applied force, so it's a little bit easier than the lab. And we're trying to figure out what's the relationship between the acceleration and the mass. So now the problem is on this graph, it doesn't give you, you'll notice there's position time, there's a speed time graph. It doesn't give you an acceleration time graph. So you're going to have to figure out, which of these graphs you're going to use to figure out acceleration. So this is a review back to kinematics. So that's kind of good. I like that part of it. So you need to figure out, okay, if I know the speed time, how am I going to find acceleration? Or position time, how am I going to find acceleration? Okay. So let's say you're doing the first part of the lab and you're doing acceleration versus the net force. You're going to be, of course, keeping the mass constant. So whatever mass you have it on, please make sure you record that down. And you're going to be varying the net force. And so you would be changing the applied force here. And then you would see what the acceleration is for that particular applied force. I think you have to hit play here. One thing, when you change these and you hit play, I think it resets, if I remember from last year. Because we had a snow day on this day again last year. And so be careful that the mass is going back to the constant that you want it to be. Okay, so be careful about that. And then for the second part of the lab, you're going to be changing the mass, and the force is going to be constant, so make sure you keep that constant. And again, when you hit reset, I think it might readjust that applied mass, or that applied force, so you're going to have to readjust that back. Okay, so where is this website at? Well, right here it is. So let me show you how you're going to do this. So you just simply type in that link, and what will happen, I hope, is that it will come to this, something like this, I hope, and you hit download. And you should see it pop up down here at the bottom, and you're just going to simply hit keep. Once it downloads, then you'll be able to click on it. There we go. I'm going to click on it. And there it starts up. And so I would set the initial velocity to be 0. That'll make it easier. But that's what we're doing. Now notice it has surface 1, surface 2, surface 3. I don't care what surface you have it on, but make sure you record that as your constant as well. So make sure you record both of those. Okay. All right. Well, have fun e-learning today. And then, of course, one last thing. Here's the response sheet. Again, this response sheet, you're not going to turn this in until after we whiteboard it. So you're going to get all your data from this lab. And by the way, if something doesn't work right with the with this address, email me or contact me somehow so I know before tomorrow. I mean, sometime today, so I know so that you can get your data. But really, what I want you to do is get your data, linearize it so that we're ready to whiteboard as soon as you come into class. And so this will be, I'm just giving you a response sheet so you kind of know the direction we're heading. Okay, so I'm giving you 4 graphs here just in case you need to linearize any of these. Okay, and then we'll be able to answer these questions then after the whiteboarding. So, okay.